Hello, welcome back. For this video, we will solve the area of this given oblique triangle. In solving the area of an oblique triangle, we cannot use the usual formula of area, which is equal to 1/2 of the product of base and height. That is because for an oblique triangle, we still don't know the measurement of this perpendicular line towards your base we call as height. But we have two different formulas that we can use here. One of which is useful here since all three sides are given. So we have a side which measures 7, side which measures 8, and side which measures 11. This is an example of an SSS oblique triangle, because all of the sides are given. And in solving the oblique or the area of the oblique SSS triangle, we are going to use the Heron's formula. This Heron's formula uses the available measurements of sides and subject it into a series of mathematical operations which will involve us to solve for the intended area. The Heron's formula is expressed in this manner. It's the square root of the product of S and the difference of S and A times the difference of S and B, and finally the difference of S and C. All of these given measurements, or all of the measurements here, can represent A, B, and C in any order. You don't need to worry, because under here we will just use multiplication, and multiplication is commutative. However, what we don't know here is the measurement of S. It's not a side, but it's actually defined as a semi-perimeter. It is computed by the sum of three sides. So you have A plus B and then plus C. And you're going to divide the sum by 2. Not 3, because it's not average. We're just going to divide the sum by 2. So in solving for the formula of the oblique triangle using the Heron's formula, let's start by solving the value of S here. Again, you can choose the side measurement which could be labeled with A, B, and C. Nevertheless, we can just simply try using 7 plus 8 plus 11, and all to be divided by 2. So the value of S here is the result of 7 plus 8, which is 15, plus 11, which is 26, divided by 2, so you have 13. This is the value that will be applied here. So we can have this for this process. You have here 13 times 13 minus A, we used earlier 7, so let's do that, times 13 minus 8, and then times 13 minus 11. So we have here the result of all of this, which will still be subjected by square root. We can use a calculator here. Let's use this calculator and let's try to compute the value of the radicand. 13 times 13 minus 7 is 6, times 13 minus 8 is 5, times 13 minus 11 is 2. Again, 13 times 6 times 5 times 2. That's 780. That's the value you'll be placing here as your radicand. And since it is still to be subjected by square root, so we just simply take square root of 780. And since it's a measurement, of course, it's positive square root. So we'll have the square root of our answer, which is 780 degrees, which will equal to 27.92848, so on and so forth. We are going to approximate this by rounding it off into 2 decimal places. So that would become 27.93. So that is again 27.93. So let's try to approximate this. Approximately 27.93. Let's check it again. 27.93, rounded off into 2 decimal places. And since it's area, we just need to complete the notations here using square. And since it doesn't have any units, we'll have square units. So the area of this given oblique triangle with side measurement 7, 8, and 11 is approximately 27.93 square units using the Heron's formula.